You would be amazed to know that the world would die because of hunger if there are no fossil fuels. How we can avoid this, let's see. Nitrogenous fertilizers play a critical role in ensuring food security by increasing agricultural productivity and enabling farmers to produce more food on a larger scale. Without synthetic nitrogen fertilizers, global food production would be reduced by as much as 40%. The availability of nitrogen fertilizers has transformed agriculture, allowing farmers to increase crop yields and feed more people than ever before. Urea, one of the most commonly used nitrogenous fertilizers, has played a particularly important role in increasing global food production. It is affordable, easy to transport and store, and can be applied to a wide range of crops and soils. Additionally, its slow-release properties help to ensure that plants have access to nitrogen over a longer period of time. The urea is produced by reacting the ammonia and carbon dioxide. Ammonia is a key component in the production of urea and produced through the Haber-Bosch process, that was developed in the early 20th century. The Haber-Bosch process is considered to be one of the most important discoveries in the history of industrial chemistry, as 50% of the nitrogenous fertilizers are produced using ammonia. The raw materials for the production of ammonia are nitrogen and hydrogen. The nitrogen is taken from the air and hydrogen from the natural gas. These are reacted to from ammonia at a high pressure of around 200 atmospheres and a temperature of around 450 to 500 degrees centigrade over the surface of iron oxide catalyst. The production of urea and ammonia, like many industrial processes, consume huge amount of energy. For instance, 10 kilograms of urea production consumes the same energy that we get by burning 1 liter of gasoline or by consuming 10 units of electricity. Moreover, this is associated with the emission of greenhouse gases, including carbon dioxide, CO2, that harms the environment. As we know, the energy is usually gained from the fossil fuels like natural gas or coal, and these resources are considered to deplete in the coming years. Hence, to ensure the food security for the humans, it is urgent to find the solution. In this regard, the research and development are going on at a greater pace for the production of green ammonia. Green ammonia refers to ammonia that is produced using renewable energy sources such as wind, solar, or hydropower, rather than the fossil fuels typically used in the traditional Haber-Bosch process. Green ammonia is considered to be a more sustainable and environmentally friendly alternative to traditional ammonia production methods, as it can help to reduce carbon emissions and dependence on fossil fuels. The key component in the green ammonia is green hydrogen that is produced from the electrolysis of water using the renewable electricity from the solar and wind. Water is electrolyzed using an electric current to generate hydrogen gas and oxygen gas. And then later on, this green hydrogen is utilized in the Haber-Bosch process, that is discussed already, and in the electrolytic production of ammonia. In electrolytic ammonia production, the green hydrogen gas is combined with nitrogen gas in a reactor vessel, where an electrochemical catalyst helps to facilitate the reaction. The electrochemical catalyst utilizes renewable electricity to convert these reactants to ammonia. Electrolytic ammonia production has the potential to significantly reduce carbon emissions and dependence on fossil fuels, as it can be powered using renewable energy sources and does not require the use of fossil fuels as a feedstock. However, the technology is still in the early stages of development, and there are several technical and economic challenges that need to be addressed before it can be commercialized on a large scale. In addition to electrolytic ammonia production, very recently a more sustainable method, by the researchers from Stanford, has been developed, which is known as microdroplet-assisted ammonia production. In this method, pumped water and compressed molecular nitrogen is reacted over the surface of the iron oxide catalyst at the room temperature. Resultantly, the ammonia produced is much cheaper as the process is simple and less energetics. If this process can be scaled up, it would represent an eco-friendly new way of making ammonia and will save 2% of global energy and reduce 1% of the CO2 emitted into the atmosphere.